Hello all and welcome back to this quick lecture where we are going to discuss about a special type of matrix which is called a symmetric matrix. So as usual, first we will go through the theoretical concept. We will understand that what is a symmetric matrix, and then we will do some practical coding on our Jupyter notebook. So let's get started. So as I said earlier, symmetric matrix is a special type of matrix that will mainly have these two properties. So first thing first, it will always be a square matrix. So let's try to understand what is a square matrix, because going forward we are going to use this term a lot. So in simple words, a square matrix is a matrix where number of rows is equals to the number of columns. As simple as that. So as we can see, this one is a 3 by 3 matrix, hence will be called a square matrix. Secondly, the transpose of a symmetric matrix will be equals to the matrix itself. In order to understand this, let's try to take the transpose of this matrix, and as we know, while doing the transpose, all the rows will become the column. So first let's transpose this row. So I will set it as a column 2 1 7. Then let's go with this row, second row. So I will set it as 1 5 8, and then finally transposing the third row. So 7 8 and 9. And as you can see, even after transposing the matrix, it is exactly the same as its original state. Okay, so I hope that now you are pretty much familiar with a symmetric matrix. So now let's move ahead and discuss about a special case of symmetric matrix, which is also called an identity matrix. So as I said earlier, that identity matrix is a special case of a symmetric matrix, and it will have all the elements as 1 in its diagonal, and rest all the elements will be 0. So as you can see here in this matrix, we have all the values 1 in the diagonal, and rest all the elements are 0. Usually we denote an identity matrix with the capital I, and since identity matrix is also a symmetric matrix, hence will be square, so we specify the number of rows, or you can say number of columns, at the bottom of I. So I3 means an identity matrix of shape 3 by 3. Alright, that is it for the theory part. Now let's quickly jump into the Jupyter notebook and do some hands-on code demo. So within this cell, I am creating a two-dimensional array or a matrix named A underscore SYM, stands for symmetric matrix. And if I'll execute this, you can see that we have the same matrix that we have used in the theory part. In the following cell, I am trying to take the transpose of the matrix, and as you can see, there is no change with the original matrix itself even after doing the transpose. If I'll execute the following cell, then you see Python is saying that all the elements even after transposing remains unchanged. Okay, now let's see some code demo for identity matrix. So here, using the NumPy library, I'm creating a new identity matrix. If I'll execute this cell, so we have a matrix of shape 3 by 3 having 1 in the diagonal. And in linear algebra, an identity matrix has a special property that when it is multiplied with a vector or a matrix, and of course you will be able to multiply if the multiplication is possible, going by the number of rows and columns of the vector or matrix. In that case, after multiplying, the other matrix or vector remains unchanged. So let's see the same thing on code. So if I'll execute this cell, we have a vector of length 3, it has 3 elements, and now let's try to multiply the identity matrix with this vector. So if I'll execute this cell, you can see the vector remains unchanged even after being multiplied by the identity matrix. Alright, so that is it for today's lecture. I hope that you have a clear idea that what is a symmetric matrix and what is an identity matrix and their properties. Stick to the playlist, and we are soon going to cover the topic of matrices within 2 to 3 lectures, and then we will move on to some other topics in the series of mathematics for machine learning. Drop a like below if you found this video helpful, and subscribe to the channel, and I will see you in the next lecture.